Welcome to the project demonstration of density-based traffic signal controlling system by using PIC 877A microcontroller. So here we are using PIC 16F 877A microcontroller, which will taking input from this 4 IR sensors which are used to detect the individual side traffic density. So whenever the vehicle presents till this sensor, then the system will came to know that side there is a heavy traffic, so that we need to provide the more time for the green signal. Otherwise it's normal time, nothing but more time, nothing but here we are demonstrating purpose we keep the normal time as 6 seconds for each side for the green light, and 12 seconds whenever the high traffic is detected with help of this IR sensor. In real time, instead of providing the green signal till the vehicle moves away from this IR sensor, so it may leads to difficult for the other sides. Instead of giving that, just we are increasing the green signal timing for that particular side. So here the operation is, whenever we switch on the kit, the green light will rotate side by side, one by one, and whenever it's coming to this side, for example, then it will, before on the green, it will check for the density level. If it is normal, 6 seconds, or else if it is heavy density, then 12 seconds green light will get switched on, and otherwise normal 6 seconds. So it's keep on rotates and it will check for the density. So coming to the interfacing connections, we have interfaced these 4 IR sensors to detect the density levels to the PIC 16F 877A at A0, E2, C0, D1. So these are the inputs from the IR sensors, and output is C6, C7, D4 to D7 and B0 to B5. So total 12 output pins are connected to this 12 LEDs here. So coming to the IR sensor working principle. So here this white color as a transparent color LED is a IR transmitter, and this black color is the IR receiver. So whenever we placed any object in front of this IR sensor, then the surface of this object will reflect those transmitted IR rays, and that will be reflected by the surface and received by this IR receiver module, so that the controller will get the trigger pulse in terms of voltage, that is a 0 or 5. So when there is no obstacle in front of the IR sensor, it will provide us the 5 volts output, and if is there any obstacle is there, then the control will get the 0 volts. So in that manner the system will identify the density or low density. So let us see the demonstration. Just on the power supply to this adapter, so which will take 230 volts AC input and provide as a 5 volts DC output. Initially all the lights will be on and off 2 times, and after that initially this side is the green LED, and as of now there is no high density was detected. So let us pass the green light with low density intensity only. So whenever we place any object in front of this IR sensor, another light will get switched on. So here we should remember one thing: without placing any object in front of the IR sensor, if the second light also gets switched on, we should check the LED position, they are already normal or abnormal, or any external sunlight is falling on this IRS. Now you can check that. So now the timing for that one is 12 seconds instead of 6 seconds. Let us place this for other side also. So if the vehicle moves also, then the time was already started for 12 instead of 6. Okay. So as I'm repeating that, you can check on the timing also. So when another external sunlight or external heavy light fall on this IR sensor module, then another light also will get switched on without any object. So we should check that before demonstration. Normally only one LED, any obstacle detects, then only another light should get switched on. So we should check that properly, then only we can go with the execution. So let us see this side. Right, now the timer starts. It will go up to the 12 seconds of the duration. So let us place the same object for other side, so that we can cover the 4 sides with the density of light. Right, this side I'm placing that. So this side was only 6 seconds the duration given, and that side now we will get the 12 seconds of the duration. So as we are using PIC 16F 877A controller, which will work under the 20 MHz of disclosed frequency, so that it can execute the 20 mega instructions per second, as we are providing the 20 megahertz clock frequency, oscillator frequency, right? Thank you.